Hey there, bloggers. Are you ready for a test? Of course you are. It's time for the Chapter 22 Probability Learning Target Quiz. It was kind of hard to decide how to organize this, so the basic idea is that you are responsible for being able to use a tree diagram, a Venn diagram, and a two-way table, as well as use all the formulas that we have gone over, which are in the formula packet. So the first thing you want to do when you get your test on Friday is you want to make sure that you find the appropriate formulas in the formula packet. All the probability stuff is in topic 5, and it's these 4 equations right here. So they should look familiar. Combined events, we also call that the law of addition. The mutually exclusive events is basically the exact same thing as the combined events, except there's no overlap. So the union of the two things happening is just the probability of A plus probability of B. You don't have to worry about any overlap because they can't happen at the same time. Conditional probability. Now this is the one that looks a little bit different in our notes than in the formula packet. So I just want to briefly go over this. You might want to rewrite it. Normally, it says conditional probability, so why don't we write the conditional part first? So if I write probability of B given A times probability of A is equal to the intersection, then I can solve it for the probability of B given A by dividing both sides by the probability of A. So I'd get the probability of A intersecting with B divided by the probability of A. Okay, so this is not how it looks in the formula packet. That's how it looks in our notes. It looks like our notes like this. So when you get the packet, do be aware that it looks different in the packet than it looks in our notes. But it is the exact same equation. And then, of course, if we had the probability of A given B, that's going to change the equation a little bit because you divide by the probability of the second letter, the given part. So it would be like that. Okay, so something to be aware of. Since you won't have your notes, you'll only have the formula packet. Be aware of that. Okay, in independent events, if you're asked to test if 2 events are independent, then they satisfy this equation. Or if you're told that 2 events are independent, then you can use this. If you do not know that the events are independent, you got to be careful with this one. Okay, so watch out for that. All right, so let's go ahead. And so as I mentioned to my classes, and so Mr. Myers' classes, I'm telling you now, level 1 is going to be a tree diagram. Okay, so I already wrote the quiz, I already know. It's a tree diagram. So let's go ahead and answer this. So the diagram below shows the probabilities for events A and B, with the probability of A not happening is equal to P. Okay, A prime means not happening. So here is the probability of A happening is 1/5. So it not happening has to be 4/5 because the probability of A and the probability of A prime has to add up to 1. The probability of something happening and it not happening is all the possible things that could happen. And so those have to add up to 1. All right, so we have P is equal to 4/5. All right, now find the probability of B. So we're going to have to do some work for this because we already know the probability of A, but this is a dependent probability thing because if we get A, the probability of B is 1/4, but if we don't get A, the probability of B happening is 3/8. So we can't just say, oh, the probability of B is 1/4. Well, what about this? 3/8? No. So what we have to do is we are going to actually have to take the union of these things. Basically, think about it. You are a winner if you get B. It doesn't matter where you get it from. So I can get it from this branch. So I can get my probability of B happening this way. So that would be 1/5 times 1/4. I'm also a winner if I end up on this branch. Okay, both of these branches make me a winner. So it's both things make me a winner, so I'm going to add them together. So here I'm going to have 4/5 plus 3/8. Oops, sorry, times 3/8. Pardon me. And then we're going to simplify our fractions. So this one is 1/20. And this one I could reduce. Do I want to reduce it? No, I'm not going to reduce yet. So 4 times 3 is 12. 5 times 8 is 40. Now in order to add fractions, we need to have a common denominator. So I can divide this one by 2 and make it as 20ths. So this is 1/20 plus 6/20, which gives me 7/20. So the probability of B, if getting B, is in total is 7/20. Okay, so one more question here on level 1. Find the probability of not A given B. So we know we've gotten B, so we know we're on either this branch or this branch. What is the probability that it was not A rather than this branch? So here, it is possible to kind of think through this logically, but we're going to go ahead and just use the formula for this. So our conditional probability formula, which I was just talking about in the packet, looks like this or this when we rewrite it. Okay, it looks different in the packet, but you can rewrite it. Oops, sorry, you can't see that. We can rewrite it as one of these. So I notice that it has B second, so it's more like this. So it's going to be the probability of A, not A, given B, it's going to be equal to the probability of A intersecting, not A, intersecting with B, divided by the probability of B. So careful with the letters. Not A, not A. Oh, I didn't leave myself very much room for this. Sorry about that. All right, so the probability of the intersection of not A and B, that would be this branch right here, not A and B. So that's going to be 4/5 times 3/8. And I shouldn't have used so much space for that one, divided by the probability of B, which we have as 7/20. And now we need to do our magic with our fractions. I'm sorry, I am running out of room. So this one, I can go ahead and reduce this. 4 and 8 reduces to 1/2. So I have 3/10. So I'm going to have 3/10 divided by 7/20. So notice I changed my fraction bar to a division symbol. Then I can rewrite division as multiplication by the reciprocal. I can reduce that. That would be 1 and 2, and that gives me 6/7. So there is the answer for that is the probability of not A given that we got B. Okay, so there's some other ways to think your way through this. You don't actually have to use the formula. You can actually kind of logically deduce it from the tree diagram. So if you want to know how to do that, ask Michael. Michael figured out how to do it straight from the tree diagram. Quite clever. All right, I'm going to take a break before I do level 2.